Hi, welcome to our pre-calculus. The topic today is proving trigonometric identities using double angle identities, problem type 1. So in this case, we want to prove that tangent of x times 1 minus sine square of x is 1/2 of sine of 2x. So what can we do here? We know some identities for tangent by quotient identities is sine over cosine. We know by Pythagorean identity that this is cosine square. So one of those cosines cancels the cosine in tangent, and we are going to end up with sine cosine. Let me show you in paper first, and then we come here. So what we had there was tangent of x times 1 minus sine square of x is 1/2 sine of 2x, if I remember correctly. Well, for this one, we remember that that is sine of x over cosine of x. For this one, we remember that is cosine square of x. We do algebra here and see sine of x, cosine of x. And we have an identity that sine of 2x is 2 sine x cosine x. Well, if you put the half to the other side, 1/2 sine of 2x is equal to sine of x cosine of x. To go and see if the software expects us to explain how does the 2 go to the other side. Let's see how picky software is. Let's go back to our page here. So first I write this thing. I make a fraction for sine of x over cosine of x, and then I have 1 minus sine square of x. All I did so far is to apply the quotient identity. So important thing, do one thing at a time. So now we have sine of, let's do our quotient again. Sine of x over cosine of x, and then that is going to be cosine square of x, and that is going to be our Pythagorean. So is that right? That's right. Now we simplify cosines, so we'll have sine of x cosine of x, and that only requires algebra. So we do that. Now comes the critical time. Does it want me to explain that we are multiplying and dividing by 2? Let's see. 1/2 of sine of 2x, and this is the double angle identity, and let's see if it's happy with that. Well, yes. So we didn't need to be finicky with that 1/2. It understood our intentions. Let's try another one. Cosecant square over 2 cotangent. We want to prove that that is cosecant of 2x. So what do we know about cosecant? Cosecant is 1 over sine. Let's do this thing on paper first, but let me write it for myself. And so what we want to show is cosecant square of x over 2 cotangent of x is cosecant of 2x. But the numerator cosecant is 1 over sine, and cotangent is sine over cosine. Oh, excuse me. Cotangent, of course, cosine over sine. I have a factor of 2 here as well. So how do you divide a fraction by a fraction? So we are doing algebra here. This is going to be sine of x and then 2 cosine of x. So this is reciprocal identities. This is quotient identities. From here to here is just algebra. This is another piece of algebra. So 2 sine x cosine x. So this is still algebra. And then this is 1 over sine of 2x. This is double angle identity. And that is cosecant of 2x. 1 over sine is cosecant. And what is that? That's the reciprocal identities. So we have a map of where we are headed. And let's see if we can convince the software that we know what we're doing. So I make a fraction, and in the numerator and denominator I'll make other fractions. Let's see if maybe it becomes too many of these fractions. Let's do one at a time. So cosecant of x then of course is 1 over here is sine square of x. So I leave the other one alone for a moment. 2 cotangent of x. So we wouldn't be accused of doing two things at the same time. So what we are doing is reciprocal. Cosecant is reciprocal of sine. And it is happy with the fact that cosecant square is also reciprocal of sine square. Now I go ahead, make a fraction and another fraction and another fraction. So this is 1 sine square of x, and this is 2 cosine of x over sine of x. So what did I do now? In the denominator I did quotient identity. Let's see. Okay, now I do algebra. The algebra I do is cross multiplication that we did leaves 2 sine of x cosine of x, and let's see if it's happy with that. And then that is another quotient which is 1 over sine of 2x. Really need a parentheses there, but let's see if it becomes as sloppy as us. And 1 over sine of 2x, that is double angle identity. I use double angle. Okay, still happy with that. And then that is cosecant of 2x. That is by the reciprocal of identity, and that handles that. Okay, so these are the type of problems you see in this section, applying double angle identities to other identities to see how the manipulation goes through, and hopefully you can go through these things easily. So suggestion, write it on paper and then do one activity at a time, one rule at a time, and then you'll be okay. Okay, so until next time, good luck and God bless.